Hi everyone, my name is Suryander, and for my CNIT 176 project, I built a DIY network security camera system using a Raspberry Pi and MotionEye framework. The business case for this was simple: privacy and cost. The current market leaders like Ring or Nest require monthly subscriptions and store your private data on servers. For a small business owner or a privacy-conscious homeowner, this project provides a zero-trust alternative. It keeps all video data on local hardware while still providing the modern cloud features we expect, like real-time email alerts and remote monitoring. So to understand how this works, we have to look at the architecture of the Raspberry Pi and how it handles this specific workload. I want to highlight 5 key architectural components: peripherals and I/O. My USB camera acts as a primary input peripheral. The raw image data travels through the USB controller, which on the Pi is part of the integrated I/O handled by the SoC. And the CPU instruction execution is regarding the Pi's Broadcom CPU as the brain. It is to perform pixel analysis. The MotionEye I used compares every incoming frame to the previous one, and if enough pixels change, the CPU triggers a motion event, and this is a heavily computational task, which is why we optimize our resolution to balance clarity with the CPU overhead. There was networking and SMTP protocols. For the alerts, we used the TCP/IP stack. Specifically, the systems used the simple mail transfer protocol so that when motion is detected, the Pi initiates a secure handshake with Google's mail servers over port 587 using the TLS encryption. The secondary storage management, as talked in class. All of this stuff has been talked in class, like the networking, the CPU, the peripherals, and now I'm talking about the secondary storage management. So I used a SD card for the OS and video storage. Architecturally, I have to be really careful with the write cycles just to prevent the system from crashing. So I configured a retention policy in the file storage layer to auto-delete files after 7 days. We also talked in class about operating system daemons. So in the Linux environment, MotionEye runs as a system daemon. This means it's a background process managed by the kernel that starts automatically and monitors hardware interrupts from the camera without needing a user to stay logged in. Yeah, so that's how it relates to class. The project goes over operating systems, secondary storage management, networking protocols, CPU, peripherals, I/O, just a lot of stuff we talked about recently in the semester. Regarding the procedures I followed, there was a lot. My implementation followed a strict setup approach. I will show a video of how I did this, but first I updated the repository headers and installed Python dependencies required for the dev branch for MotionEye, which then resulted in me having to bridge the gap between local hardware and cloud security. Because I used a Gmail account for alerts, I had to navigate Google's identity and access management to set up a 2-step verification and generate a unique app password. That way, when motion is detected on the camera, it will send me an email. And there was a lot of security problems with that I had to work around. It will be later in the video, me explaining how to do that. Basically, it ensured that the Pi can send mail without me personally having to store the actual primary password in a plain text configuration file on the device. So now I'm going to show you the architecture in action. So here's a video. So the security camera is working and it is recording, and it shows the correct name and the correct date and time. It's very accurate, as you can see. Not a lot of lag. I have set a admin password for me, and I have set a normal user username and password for them. So if I want admin, I'll type in admin, and then I'll put in my password, and I'll log in. And it'll show me my camera, and it'll show me all this. And if I go over here and I click user, and then I type in the user password, which is user, and I log in, it shows you different settings. And also, as I was doing this, my camera thing was active, and it automatically sent me an email right there, email for 9. That's the time it is right now. So even if it's on admin or on the user, I will still get emails. So I masked the grid, meaning that this whole area right here, it's already applied, but this whole area right here, the camera will detect the motion from this area of the room, but I told it not to care about this area because it's not actually facing a place where people are going to be walking, which is why this is red and this is not, and it's already applied. And so when I go to videos to see the movies that they already configured, if I have like something like, if I have something like moving over here, it's not going to detect that. It's not going to record a video. But if I have something over here, it's going to record a video and send me an email like that. After the email, that's me in the corner, don't mind me, I will go back to the local host website, and I will be like, let's see the videos. And I'll be like, I'll be like, okay, let's click on this one. I'll be like, oh, it recorded something. And it's like, yeah, this got moved. I did this earlier during my setup to make sure the masking was working properly. But it's showing that it got moved, and there's me. And there's me fixing it. But it showed that it works, that there's people working, and that it will detect movement if someone's moving like that. Now that we talked about how the masking works and how the camera detects if someone walks between this area, I would like to talk about the troubleshooting problems that occurred. As any IT architect knows, no deployment goes perfectly, and I hit 3 major roadblocks. I had a config crisis, so initially the Motion Eye service would not start, and I will put pictures of what occurred and the code I used and like here and here in the video. It wouldn't start, and after digging through the directories, I realized that the Motion Eye config file was missing, and so I had to use the cp command to pull a template from the library folders into -etc-motion eye- to give the system its matching orders. So that was fun. That was like the one major issue I had starting up this project. Afterwards, I frequently ran into Linux permission errors while trying to create action buttons and just making sure the directories were still working. So I had to use chmod+x to change the file attributes, which allowed the web server to execute the scripts I wrote. Overall, it was very long and time-consuming, but it made sense in the end how to fix it. It was just small errors. After originally connecting the computer the next day, when I tried to log back in, the password didn't work, and so I had to go through the process of bashing my computer and then using the stop systematic stop motion eye, and then the sudo my mv, and the sudo mdkr, and then the sudo motion eye init. It was a nuclear reset to manually create a brand new empty config folder and rerun the setup. It eventually worked, which is why. One of the problems I faced was trying to create an action button. Even though I don't have a physical light to connect my Pi or my camera to, I wanted to configure the hooks for the GPIO integration. And in the process of doing that, I had trouble not only finding the action buttons, but making sure that I had an accessible file, which is why these are occurring. This is a major problem, actually. For context, I ended up getting the action button to work by doing this code. And then it checked that it was a directory. It made the test. I took the test and converted it into the alarm instead. And it says that the alarm is on, which means there should be a button over here. We're working on the button, but it does say it's on, which is great. And the mask says that when we go over here, that when I click the mask button over here, that it is in fact on. I also had problems with browser caching, actually. So there was a point where my edit mask button wouldn't show up, and I learned that the browser's cache was holding onto an old version of the file, and so I had to do a hard refresh by using the Control F5 button to force the browser to reread the CSS and JavaScript layers from the Pi. It was a lot of work, and looking back, if I were to do this again for a large-scale business, I would implement off-site resources, and I would also try to figure out how to Bluetooth the Pi to the camera, since it's currently connected via the camera's wire. So I think it would be nice to figure out later on, if I continue with this project, to get the security camera to set up without being so directly connected. If an intruder were to steal the Raspberry Pi, they would steal the evidence, and so using a tool like rsync to push video to a remote server would be my next architectural upgrade. Honestly, this project taught me a lot of information regarding the class and how to use the skills they taught us. It helped me to understand that it isn't about plugging things in and truly like understanding the nitty-gritty. It's just about understanding and managing the handshake between hardware and local software, and just overall trying different things, troubleshooting, and trying to go out of the circle you're stuck in. Honestly, this was a very fun project, and it was good to understand. Thank you for watching, and I hope you found this informative. Bye.